is really based on a presentation that Sven Kupschutz gave this morning or yesterday, depending on your time zone. And we try to keep consistency between the presentations, in part to build on them, and in part to continue the conversation. And so the next slide, if I could please, is what are we hoping to achieve by defining ocean best practice? And kept it pretty informal. We want to, provide help or give a leg up or shortcuts in terms of knowing and evaluating systems that might work for some, but this does not mean that everything has been resolved. I mean, we still want to be able to have new ideas and independent thinking in terms of how we approach the data collection aspect. It'd be good if we could converge on methods for data collection. It would create an efficient and integrated repository, if you will, or approach, or set of approaches. But we also know that we do need to consider new monitoring needs and opportunities, and I'll talk a little bit about that. And of course, to have a best practice would also help in developing a standardized and transparent quality assurance process, if you will, based on thought out or clear scientific reasoning and documented practices. But we also recognize that requirements do vary regionally, and also, the questions might change. And so therefore, we need to be and remain adaptive in these approaches. In other words, we do want to help in how to go forward, but at the same time, we shouldn't be overly prescriptive in what we present. So the next slide, please, is so where are we in best practices relative to fisheries data collection? And you can think of it in terms of different scales. Globally, I have a picture there on the top right of basically a satellite image or a construction of global fishing effort. For particular things you might be able to do it. Mapping out where different fishing efforts happen. But that's really in early stages. To have a global view of fisheries, it's almost like a difficult question to pose. How do we do that? We do have a lot more in understanding, and we've made a lot more progress in terms of regionally, how do we collect data, and how do we collect fisheries relevant data? And there's a host of approaches to do it. ICES, and European, the European areas and shelves has approaches. In the US, we have surveys. It's difficult to see, but what I have there is a map of the United States. And what you see is regionally, there's different approaches taken because there's, perhaps different sampling needs and different questions that are being asked. And that the fact that it's very patchy is also indicative that locally, which is a third scale, we might be highly advanced, but at the same time, these patches show that they're not necessarily fully connected. So how do we collect data depends on, again, I said, whether we think about it globally, we're not quite there yet. Regionally, yes, locally even more, but how they're connected is still something that we could work on. The next slide, please. So not only are we talking about different scales in terms of the challenges that we have of what we're measuring, spatial scales, but we're also considering now that we have a whole host of new methods that we can use. And this schematic is one that I borrowed from Woo-Jun Lee from the University of Washington, where she nicely broke it down and saying, well, it used to be, on the left-hand side, it used to be simple. We used to measure different things. Different colors are supposed to be different things. Let's say you were measuring ecosystems or oceanography or fisheries. So those are the yellow, green, and blue. And we would do that understanding and what we were looking for, carefully calibrating all the instruments, ground truthing the instruments, and it was the way we do sort of hypothesis-driven science, in terms of we kind of know what we're looking for. And that was very dedicated and very time-consuming, planning and so on. Now, I think we all realize that the world is exploding in terms of our capabilities. And so now we have all of these boxes happening all at once. There's limited calibration sometimes, limited ground truthing, or perhaps not fully ground truthing. And the question also then becomes not just hypothesis-driven, but also data-driven. So we have a wealth of data that we can collect and look at, or that is being collected, sometimes not by people we don't really know yet. And the question is, how do we make use of that? So we have to find a combination between hypothesis-driven and data-driven. And the reason you have that little emoji there with the head blowing up is how do you make all this happen with just a massive amounts of data that are coming in. Next slide, please. So this is basically a summary of what I said before. Looking at old versus new data and methods. There's issues, of course, of we wanting to be precise and accurate and capturing the proper resolution, but we're also losing a little bit of control, if you will, by looking at this broader universe of data that's out there. Whether we need to be more flexible and also perhaps, who knows, some of these aspects or some of these approaches may actually reduce costs in terms of collecting the data. So this is the balance that we're playing with, or that we're considering, between hypothesis-driven science, which is robust, but it takes time, or data-driven science, where artificial intelligence and machine learning come in, but a play on the Hitchhiker's Guide to the Galaxy, the answer is 42. So yes, we're going to use these instruments and machine learning and artificial intelligence. We get an answer, but we don't really know how it got to that answer. So we have an answer, but not really the rationale. And there's a whole host of working groups and teams trying to work and develop the AI machine learning aspect of things. And arguments really can be made that you need both. And so best practices might be to evaluate the benefit and risks of each, and then work towards integrating them into a new framework. The next slide, please. And then, in addition to the fact that I said there's multiple scales, there's multiple approaches coming in, there's also the fact that, in my term, legacy fisheries, so the fisheries surveys, the way we used to do them, will need to evolve because of two things. One, the oceans themselves are changing. And so that's a picture there of in this case, the warming in the North Pacific of a few years ago with an El Nino, and we know that these heat waves are happening more frequently. There's a picture of changing sea ice in over just 5 years. This is in the Bering Sea, and you can see the red circles there indicating April of 2013 versus 2018, and we know that similar changes are happening elsewhere, and this is affecting how we sample in this very important area of the world. And the underlying food web is also changing. So the picture there of the krill and the zooplankton also says that, how these connections, this bottom-up connection, is changing. So we know that in addition to what we talked about before, the oceans themselves are changing. And there's also a change associated with a multi-sectoral use of the oceans. And so I highlighted two here: aquaculture and offshore wind energy. You see a picture here of a fishing vessel in a wind farm. And we need to sample in these regions. And these are changing the way that we actually conduct surveys. And the picture on the right, aquaculture, whether it's offshore aquaculture or nearshore, again, we are sharing the ocean now with other sectors, and we need to think about how do we collect data in this new, not just new ocean, but this new man-made environment, if you will. The next slide. It's a little bit of a busy slide, but the message is, and continuing on the theme of ecosystem data collection, is that we have a host of tools in front of us that we're trying to figure out. And really the bottom line is we can do a lot of things in terms of whether we use molecular approaches or stable isotope analyses or fatty acid analyses. And this table here, if you're trying to understand how the food web goes all the way up to the upper trophic levels, which is something that we're trying to do. It depends on your question. It depends on are you trying to figure out the prey size, the preferred prey size of an organism, or are you trying to figure out what the taxonomic resolution might be of the food web, and different questions will give you different pros and cons, which have to do with how costly it is, or how far back in time can you go with the data you collect. And really the message is that we're getting really good at a number of things, but there's always trade-offs. And so some data will have benefits beyond food webs. Some of the approaches can be used not just there, but to do close kin mark recapture, or provide estimates of biodiversity, or maybe in some cases you can do relative abundance. But it is something you need to understand and engage in trade-offs. And I think I'm down to my last slide, which is sort of a summary. And I try to keep it high level because I think the more important part will be how do we, our discussions that follow. So we have to weigh existing data sources, legacy data sources, against what might be current objectives. We need to evaluate multiple data streams now and their interactions. How do we put these all together? You need to think about how do we co-evolve ecosystem considerations and the data integration. And also, we probably don't have to be, or can't be, or shouldn't be too complex to start with. I mean, there's perhaps this is self-evident, that we want to take it a step at a time. So I hope I was able to cover a number of things in the fisheries data collection. There are some true and tried methods that work. They work in many places, not necessarily in all places. They're not necessarily transferable, but they work. We do need to know that there are spatial and temporal scales that we need to consider. There's new approaches that we need to consider, and also the fact that the system that we're trying to measure is also changing. So we have a challenge in front of us with fisheries and data collection in the system, and that's perhaps what I was hoping to get at, and then opening it up. And so, Marina, as you said in the opening remarks, we do have some questions, discussions, and ultimately, perhaps the group can formulate some recommendations. And we'll just post some up here in terms of getting the conversation going, and I'll fade into the background while the conversation happens. But they include, with the wisdom of the group, can we identify gaps in the data collection? Success stories, I've pointed to some of them. Pros and cons of having different approaches. Recommended steps furthering data collection best practices, and so on. And so with that, I will stop and invite comments and questions. And then we have another set of questions. But first, let's perhaps talk about the general concept of where we are in quote, best practices of fisheries data collection, given everything I said, and what the experiences of the work group and comments might be. So Marina, I'm turning it over back to you.
Thanks, Chair. So I think this is a time when we'll open it up to the floor. And if anyone has any questions or comments, please feel free to raise your hand. I've got the participants list open, so hopefully it's not, I'm not sure if you can see it on your shared screen. I don't want to be covering any of the text just yet. And can I ask anyone who does want to take the floor, if you could please introduce yourself with your name and your affiliation, and followed by your comments. Thanks.
I guess I can start. So, Cisco, you mentioned there's at different scales, there's a different, I guess, development of best practices, with the best being at a localized scale and early stages in the global scale. Are there any blockage for that to be at global scale, or what are the main elements in there that basically has made the best practices at global scale so slow to be taken on?
Yeah, so the question being, why aren't we further ahead in some ways on global scales? And it's a great place to start the conversation, and I hope other folks will chime in. You know, I think first, fisheries are very different depending on where you are. You know, highly migratory species are quite different from demersal species and different from coastal pelagic species. And, you know, they all require, you know, different spatial and temporal and gear considerations in terms of how you collect it. And so I think that has naturally resulted in different data streams and data sets and collection practices to be developed. You know, some of them are just, you know, I think the challenge of doing a highly migratory species data collection is simply, you know, just the huge scales that are involved spatially, and to do a fishery survey of say tuna over the North Pacific would just be daunting to do, right? However, there are methods that we could use in terms of you know, using the fishing industry to get some of the data. So not necessarily a fishery independent survey, but a fishery dependent survey, which is what we refer to. And nowadays, perhaps even bringing in some of the satellite and remote sensing approaches that are available that we didn't have before. So you might be able to look at fleet behavior, fleet dynamics, and infer from that also, you know, what the fishing practices are, and perhaps even go further than that and try to infer data from that. Others might just be, you know, too local and a completely different set of questions. So I think the challenge of the global of a global approach to doing fisheries data is simply the diversity and the size of the problem. That's perhaps the easy one, but I'm going to invite others to comment. You know, I've got a whole host of really good people online here. Anybody else want to talk about ideas on how to tackle the global scale of fisheries data collection? I'm going to pick on somebody if you don't say something.
I guess if
yeah, go ahead.
So you talk about the diversity and the size of the different fisheries at a global scale, but do you think there are sort of some basic elements in the data collection, some basic information that will be needed regardless of the diversity of the fisheries and the size? That could be, I don't know, I'm thinking about when you're doing your survey, for example, that make sure that the metadata that you collect, it's, you know, fulfills these elements. So when global studies are done, you know what the data, how the data was collected, for example. Or on the other hand, it's like when you're collecting the fisheries data, you know, the type of biological parameters that you take, these are the basic elements that need to be included, for example. So I don't know, something that is just independent of the the diversity or the of the size of the fisheries?
I have an answer, but I want to invite some other folks to comment. Anybody want to help out here? Matt, did I see you go off mute?
Yeah.
All right.
Yeah, I'll help you. Given that I work for you, it'd be a good idea to speak up. So Matt Campbell, NOAA Fisheries. I work in the Southeast Fisheries Science Center. I'm principal person in charge of a reef fish video survey. So demersal fish, they don't move a whole lot, so I don't know that we think globally about it. But one of the initiatives that we have in the Southeast is not just the U.S. Gulf or Atlantic, is also the Caribbean. And of course, those fisheries are all very interconnected. So one of the things we've been trying to do to work at least a little bit beyond just our region, but across the basin, across international jurisdictions, is to try to bring in cost-effective ways in like the Gulf and Caribbean Fisheries Institute, for instance, where we can interact, but also bring technology, workshops and sessions where we can train individuals in other jurisdictions about methods that we're using. So I'm talking primarily about video. So we've been training some partners in Puerto Rico and the USVI in particular to read videos and how we go about that business. And then one of the SIs that NOAA's taken on is automated image analysis. So one of the things underlying this work with the Caribbean is also to try to help them produce the detection algorithms and things that they're going to need. And I think that stands a chance at least of getting some standardization of methods across regions. And then of course, I would say too with the Caribbean, one of the things that's very common for us to sort of have to try to engage with is that the level of resources that they might have in their countries is far less than the resources NOAA Fisheries can bring to bear. And so one of the things that we've been trying to do is like the Viami software, which is shareware. So find inexpensive ways for them to interact and use tools that are becoming more commonplace where we work. It's not quite globally, but it's sort of approaching probably what might be needed. It's a very, very difficult and challenging problem. I'll tell you that.
Sorry, I was on mute. And Anna's question is a reasonable one, but it you know, in terms of how do we, are there, I don't know, maybe you're asking, are there underlying fundamental variables that everybody should measure, right? You know, and all, you know, then you default to, well, you might default to, you know, temperature, you might default to, you know, ecosystem health, so however you measure that, you know, and that was the part that I'm talking about, how things are changing and how do you actually include the ecosystem part, the ecosystem component in your assessment or in the fisheries data collection. But again, I'm also waiting for some other folks to perhaps chime in here, because this isn't supposed to be a one-way conversation. Hopefully other people can contribute to the conversation in terms of what might be next on the global scales.
You know this?
Yeah.
Tim was handing him out. He had a box that he was handing out to people.
Yeah, I'll go and talk to him. Thank you.
Around, so that's exactly what they want.
Yeah, that's pretty.
This is Allison Watts at the University of New Hampshire. So I am not actually a fisheries person. I'm mostly in the genomics and eDNA session. Can you hear me?
Yep.
Yep. Okay. So what we're really, since the focus there is eDNA, but one of the things that we are doing in our research group very much is working with the newer technologies of eDNA and automated autonomous systems. and combining that also with acoustics. So using these emerging technologies combined with autonomous systems, can you start to develop systems that basically go out and do transects just automatically on a certain time scale, and that provides you with a consistent data set that could be global and that could be used as a benchmark for other types of data collection? That's really a question, since I don't know if that's doable or not, but
it is, and the molecular eDNA omics approaches are indeed one of those that would be really interesting, and we can even do them, as you said, by deploying gliders and begin to characterize the broader, larger parts of the ocean. And that was part of one of the figures that we had in there had to do with eDNA might tell you some things like the biodiversity or the composition of the food web, and that's an important part of ultimately what sustains a fishery, or the changes in the fishery productivity, if you will, as a response to that changing underlying food web. Characterizing, using the new methods to characterize ecosystems that way is certainly something we haven't done. It would be certainly quite interesting, and we're getting to the point where some of these gliders and unmanned systems can actually be quite robust, and they could provide a first cut towards characterizing some aspects of the global ocean productivity or the global ocean diversity. So yes, that's definitely amongst the new methods. Going from there to actually using some of the data for assessments and estimating abundance of fish, which is in part one of the things that we try to do, is of course still a little ways down, but I think the idea that you laid out of not having to depend on ships, but being able to use other platforms to begin to characterize fundamental variables of the ocean is a very important one.
that sort of gets you to having different approaches. So having multiple approaches with different purposes being deployed in the same region.
Yes, absolutely.
I was thinking of something along those lines of of collecting data that you can't always get on the survey, especially because a lot. So I work in the Gulf of Maine at the Gulf of Maine Research Institute, and a lot of the data that I have now with surveys, temperature and salinity are collected, but historically that wasn't always the case. So would it make sense to maybe have those gaps filled in with modeled temperature data, such as something from FVCOM or another modeled temperature source? Because I'm just thinking, not only for surveys that didn't collect it historically, but maybe for other surveys in other areas that don't have temperature and salinity collection normally.
Yeah, it would be yes. The answer is yes, and we're just several groups worldwide are beginning to look at say climate and fisheries interactions using models, Earth system models and such, maybe the hard question is there, or the hard question is there is we really have a hard problem in that the kind of things that we try to project or look forward in terms of what's happening. Maybe I'm launching off on the climate part, and you were talking about near real time. Is that time scale of say the 6 months to 2-3 years, which are some of the questions that we ask in fisheries. I think that's it's a really good problem that you're asking. And so what data do we need to feed those models that will allow us to project again on those timescales of 6 months to 2 years? Or maybe you were thinking about filling in gaps at shorter space timescales. Maybe you're not. You were thinking at say weeks to months as opposed to longer. They can. I think that it certainly is possible to use models to do that, and it's a step forward, and certainly in the ecosystem approach to fisheries in terms of how to fill in some of the things that we can't directly measure. So the coupling of models to provide either information of missing data or to tell you where you should collect data, I think are two ways forward to use models. So you can use models to say, if I collected this data, I'd be able to tell something about a certain part of the world that I don't have data for. You know, the idea of an ocean of an OSSI, right? An ocean simulation experiment, an observing system simulation experiment. Those would be the kind of things that might tell you where you should collect data so that you have information, you know, to fill in the gaps that you're asking. And I think that was, you speak about the Gulf of Maine. I know Dennis McGillicuddy and others conducted OSSIs, again, these observing system simulation experiments to see where does the zoo, you know, where do you need to take measurements to find out what the zooplankton distribution would be and where you would collect it. So that's a very good point as well. The use of models to determine where you should collect data, or using models to project forward from the data that was collected. Any other thoughts? I'm going to pick on people I know here, and then I'll pick on people I don't know. Rick, can you hear us? Do you have any, Rick Mathot, do you have any thoughts on, you know, the comments that have been made? You know, maybe starting with you know, the challenges of the global measurements, or what is a relevant global measurement, or what are global relevant measurements to make?
Yeah. Thanks, Cisco. And for everybody, I'll be speaking tomorrow afternoon at the same time slot on assessments. And there I'll be talking about models that assimilate, they assimilate the sort of the final version of the data. You know, some of the derived quantities that we get from surveys, like an index of fish abundance, or the distribution of ages of fish or lengths of fish, are the kinds of things that we put into the model that come from the surveys and come from monitoring the fishery. So when I think about one of your early slides, Cisco, about moving away from a survey approach that is so dependent upon highly calibrating, so we have high consistency in our observations from one year to the next, and using that consistency as the main standardization issue. If we move away from that, we essentially are moving to what I call a more model-based approach to interpreting the survey. So rather than relying upon an old approach that might have used a standardized random survey design and just use the means coming out of that design, instead to use a spatial model to interpret the survey observations. It's more of a big data approach. It's more of a approach that uses the data as they come and interprets the data according to a spatial model of the distribution of the parameter of interest. And it's a different way of looking at it. It's something that comes closer to linking up the models that the data will eventually be used in with the ways in which the data are collected. So how does that help us? Well, I think it's the kind of thing that very much can help us use observations from ships of opportunity. If we have some sparse global scale of, not global, but you know, widespread survey that's rather sparse, but gives us some calibration over space, even an eDNA survey that could give us presence, absence of fish over a wide area, to give us some interpretation ability. And then if we can use observations from fisheries and other things that may not be going everywhere, but if we interpret those observations against a field that comes from something like eDNA, I could see us marrying up some of the different technologies in a new way to to derive information.
I think that's a very good point. You know, piecing together, that's perhaps, I don't know if you can see that the picture on here, which is this tile of different data sources to do exactly what you said, you know, picking and choosing, calibrating, et cetera, to kind of weave this new picture. And I think that's that, you know, the idea of limited calibration, limited ground truthing, but knowing how to eventually how to use that. I think I think that is something that we are thinking about. I'm not sure, you know, we're making progress towards it, but going back to Anna and Allison, I think that those are the kinds of approaches that we could take to stitch together. Maybe that's the way the word I'm looking for is stitch together different data sources, and then perhaps integrating it with the models, as you said, Mackenzie, to then work towards a global representation of certain variables. Marino, you changed slides. Did you want to follow up on some other questions? Or does anybody have any other thoughts or comments on where we were before?
Yeah, thanks, Chair. I guess I can probably give some perspective from the Pacific, from an operational perspective, from the tuna fisheries. Just looking at, I guess, bullet point 3 here, we look at kind of the standardizations of common data fields. And the way we've done it is most of the Pacific Island states have the scientific service provider, SBC, who have developed subcommittees that look at some of the required fields from catch and effort observers, and also some of these emerging technologies, electronic reporting and electronic monitoring. And so it's looking at what information is needed that feeds into the stock assessments that they undergo for us, and they will develop the standard protocols and policies needed, which eventually gets adopted by the Western Central Pacific Tuna Commission. So there is a pretty robust system that we use to ensure that we kind of capture all of that. Another cool initiative which SPC has developed is a centralized database which is available to its 26 member states, and that captures, it serves as a repository for all this catch and effort information, as well as vessel monitoring information that we can use to look at the monitoring and surveillance component of the fisheries. So it's a pretty powerful and useful tool that we use within the tuna space, but also when we look at some of the coastal fisheries as well. So we're moving away from the traditional paper log sheets and implementing new applications that we can use on the field that is user-friendly in these remote locations, very little internet connectivity required, and that's feeding into a lot of these stock assessment activities that SBC undergoes for us. So I just thought I'd provide that perspective from the Pacific, Chair. Also, I'm looking at the time. There is another set of questions. I'm not sure if you want to move to that, Cisco, now, or would you like to stay on these questions?
Well, let's see if we just left this on for another minute. Does anybody have any thoughts on you know, how we could contribute? You know, in the end, remember, we would like to submit a report, you know, or at least of how we discussed in terms of, you know, best practices on data collection. I mean, we've talked about the challenges. We've talked a little bit about the best practices. You know, I don't know if anybody wants to comment on or ask any questions in terms of um, moving towards either furthering fisheries data collection. How do we integrate the data that we have with other groups? Whether it's GOOSE, the Global Ocean Observing System, or like Marino said, with other fisheries databases and so on, and the challenges of interoperability between these databases. Or, maybe some of the questions that we're talking about here are really what we're pointing at is having a follow-up discussion in a future workshop. Maybe we can fine tune some of the questions of best practice, either so that we address questions like what are relevant data that should be collected to as first steps towards a global database or global something or such. So it's really, remember, this is the idea of these meetings are to have a workshop. So, we invite everybody's thoughts and comments in terms of what you think. I mean, there's no right or wrong. We're trying to figure out, how to contribute to this discussion of best practices. So if you have any thoughts, please let us know.
I'm wondering, like, what your thoughts are on including surveys that aren't randomly stratified. Like, for example, for Maine lobster, the ventless trap survey, which was industry-led, wasn't randomly stratified, but it provided really useful information on younger lobsters that the other surveys didn't capture, but it took a long time for that survey to be used in the assessment because it wasn't randomly stratified. So, I guess, like, how could we overcome challenges in surveys that aren't randomly stratified and using them in assessments?
Rick, you might have some thoughts on this one.
Yeah, I mean, the important step is to get people together and talk about the data and how they might be used. And I think I can imagine that exact thing happening, what you described. But if you have spatial information on where they've been collected, it's way better than having no information. And there's a long history of fisheries assessments using data that is simply the logbooks from fishermen when they're doing their usual fishing practices. So any sort of a survey that is using somewhat standardized methods is going to be almost certainly better than the information you get from fishermen when they're out there doing their business. They're out there even trying to do a survey. They are doing activities that can be interpreted as an index of fish or lobster abundance, but it's not nearly as good as something that has a better spatial distribution and some degree of standardization. So, I think, if you can have a conversation among the people who are using it, and there will be a diversity of people involved on both sides. People who feel very strongly about stratified random survey methods versus those who are looking more into model-based methods. And similarly, on the user side, there are those you'll find who will be really looking for highly standardized over time, and others, have been working towards adopting methods that are more flexible than that. The fields are always evolving, and having a conversation, spinning up a workshop, inviting some people with a diversity of perspectives, I think is the only way to move forward.
And the part about overcoming the surveys that are not randomly stratified perhaps is working on understanding any biases that might be in them and using that. Is that fair? Fair
enough. Yes. Very, very true. Stratified random, certainly is a statistically well-founded approach, but it can't overcome, all issues, and it may be only marginally better than something that is not as highly laid out on a statistical principle. Some of it can be overcome by taking a very careful spatial approach to the analysis of the data can help you overcome those initial sample allocation design changes. So I've put a post on the chat about something with regard as a way to access some fairly widespread bottom trawl survey data, and that has followed up with some additional information. Nat, I wonder if you could talk a little bit about the website that you just put up.
Sure. So it's just one that I'm aware of. I guess my thought was before we go and reinvent the wheel, there are groups that are taking global sort of perspective towards collecting data. One of those is Global FinPrint, which is shark data. It's essentially photographic shark data that people are collecting around the world. I'm familiar with it just through a graduate student at FIU that I was helping he was working actually in Tetiaroa in the South Pacific, but he's also worked in the Caribbean. And then there's, if you go to that website, you'll see kind of where information's being collected. So that's kind of my extent of it. So I don't know what their sort of data criterias are for being included in this kind of an approach. I just know that it does exist. And so surely they've got some kind of standards that they're developing, at least for whatever they're doing. I know it's targeting shark abundance, sharks and rays.
You find other sites that have pulled together a lot of coral distribution data. I don't know it in particular, but that's another sub-discipline of living marine resource monitoring that has banded together over wide regions to pull together information. I'm sure with some good search words you could find it.
So I clicked on the link and I lost everybody. Am I still on?
You are, we can hear you.
Looks like you're still here.
But I don't see you guys. Where'd you guys go? Oh no, what did I do? I have no idea.
Zoom again. Like it should be somewhere. It's just, yeah. Put your mouse where the Zoom icon is.
So now so this might help other people. So now I'm seeing a bunch of sharks, but I don't know how to get where I was before.
Well, go to you should have a zoom, which looks like a camera at the bottom of your screen. Click on it.
There you are. Okay. I'm back. Okay, thank you. Thanks for that. And there was a question from Fernando. Fernando, did we address your question, or this thing that I guess Fernando asked a question if there's a map where we can see where data is actually being collected and where there's no collection of data. So I guess you're just trying to find a map of global fisheries efforts. Is that your question, Fernando?
And another source that's always worth checking in this regard is the FAO websites. FAO certainly works to pull together information over broad areas as well. So I think that's worth looking into.
I think there was a question in there also from Fernando about the artisanal fisheries fleet and the lack of data about it.
Yeah, I'm not sure I know how to comment on the artisanal fisheries.
Yeah.
Anybody on here can do that?
Well, this is Rick again, and I could comment from the perspective of what I'll talk about a little bit tomorrow, and that is what we call data-limited methods for assessment. And they're an attempt to try to get some information on the status of fish stocks when we don't have surveys to go off of. And some of those methods use just very little bit of life history data to try to infer how productive the fish stock is and whether or not it's the life history it displays today is much different than what we would have expected for a species like that if it wasn't fished. And that's basically how those techniques work. And they try to give us some idea of whether or not a fish stock has been highly impacted over time or not. But that's only a starting place. I mean, the next question that always gets asked is, especially if you find that it has likely been heavily impacted, it's how to go about collecting information. And you know, there's nothing better than to start collecting a time series so you can compare changes over time. And you know, it's starting with you know, probably partnering with the local fishing industries or the artisanal fisheries to develop some citizen science approach, some cooperative science approach, so that you know, they can start collecting life history data, you know, recording the average size of fish they catch over time. Things like that are all indicators that can be used in models. And you know, so you know, if you have people who are there and are going to be able to work locally, you know, it's one way to go. If you can't start time series, or if you can't be confident that you'd be able to maintain something standard over time, then it's very difficult. You know, because we don't have techniques to go out and measure the absolute abundance of all components of the ecosystem. We just don't have the technical means to go out there and you know, freeze a cubic meter of water or a cubic kilometer of water and slice it up and count everything that's in it exactly as if we could do a 3D quadrat sampling of the ocean. We wish we could. You know, some of the acoustic methods can help, some of the optical methods can help, but it's hard to get to absolute abundance in the ocean. And it's a whole lot harder than counting trees in the forest. So it's always going to be a big challenge. So relying upon indicators over time is really what we need to do. Just work on measuring how the system is changing.
Thank you, Rick.
I have a question. When it comes to creating a global standard for maybe model-based indices, what are your thoughts on vector autoregressive spatio-temporal, the VAST model, that it can incorporate spatial and temporal correlation really well? And it seems to be used a lot in the States, and I know it's being used increasingly on the East Coast where I am, and I'm just wondering if it's used in other countries, and you know, if this seems to be the model that can be like a global standard for model-based indices.
Well, today it's where I'm putting my money, if you will, on the kind of techniques that can do that. You know, I know the developers of that pretty well. And they have been working throughout a lot of the areas of the U.S. The Ocean Adapt website, the people doing that are working with Jim Thorson and others on applying those kind of techniques in order to, you know, take the data over space and develop from that a model of the distribution from which they can measure the degree to which distributions have shifted over time. So it is being used. The degree to which it's being used elsewhere, I'm not aware of that. I'd be surprised if it hasn't started to migrate. That's the way things, you know, there's good communication. It certainly has been presented in international conferences, you know, IC's annual science conference, for example. So, you know, I would expect that over time, you'll see more adoption of that method. And, you know, it's the kind of thing, I have one student right now with Jim Thorson and others, and Andre Pont. And this, what we're looking to do is actually combine survey data and fishery data into one map. And so that the fishing boats, yes, they're using different methods, but they're out there, they're certainly detecting presence, absence of fish. And we can use that in one combined map. And when I mentioned earlier, well, how could eDNA fit into this? Well, if you had a really synoptic picture of fish distribution, it's not highly quantitative to the same degree as actually counting fish, but you can get a big map pretty quickly. And so if you have the big map from that and you analyze it with VAST at the same time, you're analyzing data that's not very many places, but highly quantitative at those places, then maybe we have an approach that could combine things and help out.
I have another question. So you talk about the use of models and indicators because we cannot really know how many fish are in the ocean. And I wonder if there are opportunities in there where there is a big observing community, ocean observing community, for now starting to integrate what the fisheries community is doing with what the ocean observing community is doing and combining efforts, because there's a lot of information out there that could potentially help produce those indicators or help some of the models that are used.
We picked on poor Rick quite a bit. Any other, again, in the spirit of a workshop and discussion? I mean, I got some thoughts, but anybody else want to offer up some ideas? So I think I'll start. I mean, I think that we've touched upon some of them already in terms of observing systems, being able to provide some data that like we talked earlier, through models and others, could be stitched together, in ways that we haven't seen. I think that the migration of fish is something that we're looking at, and eDNA has been one of the approaches that has perhaps talked about detecting fish in places that perhaps normal, whatever, more standard measurements haven't seen. So I think that as the methods evolve, having observing systems in key places to see how the distributions of fish, maybe some abundance estimates as well can come in, is something that's important to do. I think that, and observing systems these days aren't just moored systems, right? I mean, I think that now, as was mentioned earlier, if we deploy gliders and think about observing systems more broadly, not just perhaps the way that we used to think about observing systems in terms of fixed sections or fixed moorings, there definitely is a big opportunity to marry observing systems with fisheries data collection. I mean, I think that they're complementary, and like we said earlier, they can provide data that, like ships of opportunity can, and so on, that we didn't have access to before. I think one of the tricks is, of course, the calibration and understanding what the different data mean. But I think that certainly is, I feel it's a recommendation that's worth thinking about, of how to evolve the observing systems in a way that can be dovetailed with perhaps our fisheries data collection strategies. I think that's a ripe area to explore. I don't know if there's other thoughts on that from other folks.
I think one useful thing will be basically for all these observing system networks to have some of the feedback and input from the fisheries of where the needs are, and vice versa, because and in there I'll sort of put the fishing industry, where they might actually go to places where they could actually provide us with data to improve some of the models, climate models, etc., where they can put some temperature loggers and stuff like that and make them available. So I think it's a two-way thing that could actually help both networks.
Agreed.
Cisco, I have a question. You mentioned the possibility of autonomous platforms, gliders, many others, etc. Are there any developments going on in the community where special sensors for the fisheries can be put on these autonomous platforms? We're dealing with low power, certain data rates, etc. That would be useful looking forward.
I know that examples have been used for detecting harmful algal blooms and other probably most of us are familiar with that. So I think if you have the right thing that you're looking for, the right primer, the right whatever, and I know that there are some eDNA folks on the call, or at least there were. So Allison, if you can speak to this, this would be great. But I think the answer is yes, we could. I don't see why we wouldn't be able to, deploy some of these gliders in a way that we could be sampling for certain things, certain targets, if you will, just the same way that we're sampling for harmful algal blooms and other perhaps lower trophic species that have been successful. And these have been actually quite successful in terms of even as early warning systems and so on. So if it worked for one, I presume it could work for the other. But Allison, if you're still on, can you comment on how the eDNA evolution on unmanned systems might be?
Yeah, so I think there are a couple of, I was just on a workshop last week on eDNA technologies. So there are a couple of systems that are being built that are really designed for gliders and autonomous systems, like Monterey Bay Research Institute has one, and there are a couple others that are being built for that. I just saw, and I know nothing about it except that it looks really cool, something that's being built by Dartmouth Ocean Technologies. It looks like it sits on a buoy, and it's intended to sense both nutrient levels, so basic water chemistry, and then specific primer targets. So it looks like it's designed to pick up like maybe 5 things, but it's a combination of both chemistry and genomic data that would sit on a buoy. It was designed for aquaculture monitoring. So I think that technology is really starting to grow. It's probably not, it's not within common use, and it will be a little while, but it's definitely in growth.
I could add to that our lab is trying to develop in conjunction with the physics lab at UW device like an autosampler that will be in the shape of an Niskin bottle, so it can fit in the CTD, so it can do both things at the same time, filtering water and collecting the samples for you while it collects all the data. But it's going to be tried soon in this month. So we don't know if it works.
That's cool, because the other workshop I was in, they kept talking about how we need to be able to do eDNA from Niskin bottles better. So someone's working on it.
Krista was in the meeting before, but since she's gone, I just thought I'd chime in.
So the answer, Jay, is yes, and I think there's a lot of promise for this. I think it's beyond nascent. I think we've had some very successful proofs of concept. So I think there's good reason to be optimistic that this is a very a real way forward.
Yeah, it's very, very exciting. And for the years I worked on autonomous platforms, this is one thing we had dreamed about. Does that mean that we should start talking about best practices for some of these things before they get too widespread? So there's a way to keep people doing the same thing?
So I'd say for the eDNA, there is a best practices session in this meeting.
Oh, yeah.
But I'm also going to throw out into this discussion the issue of big data. So when you start talking about genomics and acoustics and probably some of these, you get these huge data sets. that I don't think we have any really good idea how to manage. So just throw that into the conversation.
Yeah. Jay, you ask a very interesting question, because when a technology is developing rapidly, there's still a lot of innovating going on. You know, it's too soon to have too firm of a best practice, because you still want further evolution. You still want more experimentation. So I don't have an answer for this, but I certainly recognize the challenge of you know, retarding development by developing a best practice too soon. And again, I don't have an answer for that, but it's a curious thing to, I think, to think about in this practice. I also put up something that we've been doing. You saw in Cisco's slides, a sail drone. And we've been working on putting acoustics on a sail drone, an autonomous sail drone that's out there for months, and collecting fishery acoustic data. We also have attached, basically put a hard drive on a fishing boat that has acoustics, and get acoustic data from a fishing boat as it steams back and forth. So try to put technology onto platforms and use the word platform really liberally is I think something that is well worth doing.
There is also acoustics being used in gliders. Can remember someone from in the southern hemisphere is using gliders with I think it's multi-frequency acoustics.
Yeah.
And also there is some experimentation with animal tagging for seals in the Southern Ocean, but they're putting acoustics as well. Don't know how ethically is that, but they are doing that too.
Yeah, the animal tagging is quite remarkable. I don't know how you'd have to tag a lot of animals, maybe. I mean, but you certainly get a very good idea of distribution. Barbara Block and others have done some really very nice work in terms of migration in the Pacific. That has allowed her to talk about the Serengetis of the ocean and so on, in terms of why fish would migrate to certain places for either as nursery areas or feeding areas and so on. And that's of course important in terms of understanding the spatial structure of highly migratory species and such, which we talked about earlier about some of the challenges. So those have also been quite promising results. But getting to the big data problem that was brought up is the acoustics problem is a huge problem, because as you said, somebody said multi-frequency. So now we're collecting a vast amounts of data with acoustically. The genomic data is huge as well, the molecular, and I heard some people saying that the molecular data is soon going to be even bigger than satellite data in terms of amount of data. So I think that does bring another aspect of data collection is, how do you handle all of this? And I think that's your point about big data being as important perhaps as what we're collecting and how much we're collecting. But then now what do we do? What do we do with it now that we have all this there? I'm not sure if anybody has any thoughts. Maybe it's come up in other contexts, but the now what is an important part of this as well.
Perhaps actually linking with the satellite community and see how they deal with it might give us some clues, lessons learned, I guess.
I was talking to somebody in the satellite community just 2 weeks ago, and it made me nervous. They actually throw away some of the data after a while because they can't keep it. It's just too much. And so, I think most of us here know how hard it is to collect data, and to think that you have to flush the data eventually is a little bit against the grain, perhaps. But question is, what's the best practice in terms of how do you decide? And it's a very good point. I mean, to talk to the satellite folks and say, how do you decide what data you can flush? And that might be as important as a question of what's the data that you keep. So I think that's another very good point. Let's see. We are just getting going here. And what time is it? I just want to make sure, I want to be respectful of everybody's time. And I lost
Yeah, we have about 10 minutes
10 minutes.
for this session. Yeah.
Any other, okay, there's a couple of questions that are being posted. Okay, Rick looks like you answered the question on data poor, the data poor question. Have we missed any questions that have been posted to the chat, or have we captured all of them? I think we've got them. Marino, did you want to go to the last set of questions? And you know, since Jay is on, and I think of, when I think of OBPS, I think of Jay. Maybe Jay, you can help us out with some of us who are not as familiar with OBPS in terms of how you advise us in terms of thinking about this. How can OBPS support your community in aligning related methods and eventually converging? Pick any one, Jay. I mean, I don't know if you have any, you've been kind enough to listen to this conversation here, and you've probably seen us thrashing a little bit. But what ideas come to mind in terms of how this community, which I don't think is working as closely yet as we will, benefit from all your lessons learned so far?
Yeah, we welcome the fisheries community as a participant. I've been hoping for that for about a year, and it's exciting to see the working group in action here. The best practices is not something that the Ocean Best Practice System creates. It's a creation by the community of the things they do. We're a repository in which we keep the best practices. We try and make them available, the basic FAIR principles, findable and accessible. And we do that through ontologies and fairly sophisticated digital capabilities. But I think we've had many questions asked of us. For example, how do you deal with versioning? What if best practices change over time? Can we deal with that? How do we decide what is a best practice? Because there may be 3 or 4 practices, each relevant to its own area, the Arctic or the tropical areas, and how do you decide what to do? And the problem came up because people using the repository would find 100 responses in terms of methods and wouldn't have any idea what to pick. So we've had a challenge of what we call recommending best practices. How can that be done? And getting feedback. Somebody was saying today, maybe a booking.com rating system. You know, many different suggestions have been made. But we're most interested in what your community needs, and then how can we create the structure to make that readily available to all people. And if I had to say to you, what should you be offering us? It's how to answer that, how to make recommendations on what's best, and important, how do we get feedback from the community whether something is working or not.
Thank you. And as you saw, and maybe you've seen it in other communities as well, you know, although there have been some very excellent suggestions on how do we integrate things, you know, and many times we immediately go to like, well, everything depends, you know, and so we very quickly go to that. And maybe that's just part of the learning, you know, becoming comfortable with the idea that it depends, but there still might be a best practice that emerges from these. And you know, maybe you can offer some solace to say, no, you're not unique in the starting point, which is that we're not sure if there's a single best practice. There's it like you said, it depends on a number of things. But
yeah. I would add to that, Cisco. This is a very interesting discussion, that we don't require a practice to be best to be put into the repository. We learned a lesson a long time ago when somebody said, I have a really nice method, but I don't know if it's best, so I'm hesitant to put it in. and we moved back far away from a best practice to just methods, and figuring that the methods would engender dialogue, and it would get the process started of expanding the discussion. So in the work that we're doing here in fisheries, which I have a lot of interest in, just simply putting your methods in, even though they may conflict with other methods, is a real step forward.
Thank you. Thanks, Jay. Of course, we're not quite sure how to put things in, but that we can deal with that later.
Yeah.
Um,
Well, then if there would be a way to record how often the methods get referenced. I mean, if you could go into the primary literature and pull out from methods there, you know, what are they using? And then reference that back to the database to see which things are actually being used.
Yeah, indeed. Any other questions or thoughts from folks that are formulating?
I put something up there in the chat that occurred, like it hits us a lot, both when we went through our PAR exercise, which is the kind of freedom of information for all our data within NOAA, but documentation, the metadata associated with whatever data set that you have is really critical. And then not just in the sense of fisheries data, I encounter this a lot with mapping data. So multi-beam bathymetry, depending on the instrumentation, how it was set up, and so forth, you can get kind of different resolutions and all this across mapping information. Some of it's more useful than others, but having the metadata to understand how it was collected so that you don't have to track down the originator of the data necessarily to figure out what happened is real critical. And so if there's minimum standards on metadata kind of information, that could be something that this group maybe could recommend or focus on. Because I could just imagine trying to standardize across people who communicate reasonably well, like within CMAP. It took a good 20 years to get everybody standardized on something like CPUE. Detection, of course, would be a lot easier.
And so that goes to the whole point of interoperability. Is that what you're saying in terms of understanding how things were collected and knowing how to plug across them? Right. That's a very good point.
Yes.
And that goes to some of that early part that, we have regional differences and sometimes in some places quite advanced, but then we don't know how to implement a crosstalk between the data, but the metadata might allow us to do that. So I think that's a very good recommendation. Given that we will probably continue to do things differently in different regions for good reason, but that doesn't mean that we shouldn't understand that and then be able to step forward. Excellent point.
I would like to add to that point. We create templates for metadata as part of our best practice process. And we don't have one for fisheries. We have them for collections. I have one for harmful algal blooms. In line with what Matt is saying, maybe we should make a recommendation to update or create a template for metadata for fisheries, which we could do if the community is interested.
I think that would be a very good. I'm assuming most. Well, can I just ask if any comments on that? But I think that would make sense. Matt, any other thoughts on that, Matt? Or maybe you guys are already beginning to think about that?
I mean, of course, within our organization, there are metadata standards that apply for fisheries data sets. So I don't know how we can maybe take lessons learned from that or any kind of structure. I don't know. I don't know exactly how that would work, but we could look back through all our PAR documentation that were the minimum standards, at least for NOAA.
Yeah, and I think this ties back, Jay, with the questions that are on the screen right now in terms of this idea coming up and us working with OBPS to see how to do that. I think that would be good. Allison, did I see you asking a question maybe or not?
No, I'm wondering where my tea went. Don't bother me. I'm just trying to figure out where I put it.
Okay. All right. Let's see. We're almost there. Again, I want to make sure in case you guys are moving on to another thing. I think we got 2 more minutes. Are there any other thoughts? I think we've come up. Can we do maybe a little recap on some of the ideas that came up? I think we started off talking about, and I want to recap perhaps the discussion. How do we make progress towards global variables or global approaches to our problems? Let's see. We talked about the use of various systems, whether it was modeling, novel methods, et cetera, to work towards stitching these different measurements or estimates again to construct a more complete picture. We talked about most recently the metadata, the importance of having the metadata issue. What am I forgetting? I'm speaking off the top of my head here. What other things have resonated with folks? The big data came up as well in terms of we're collecting a lot of data and what do we do with it? And then talking perhaps with best practices that might have arisen in the satellite community of how to deal with the overwhelming amount of data. Let's see. Marino, are you still there? We have it all written down, but I just wanted to see if we could just do a quick recap in case somebody wants to remind us of something we forgot or emphasize something that needs to be emphasized.
Yeah, I think you captured most of it. Go ahead, Matthew.
I just threw up something in there about availability and accessibility information. So that was knowing a data set exists versus having access to a data set, especially when you start scaling up spatially across organizations. I can imagine that is challenging. So I guess that would just fit in under metadata, but
that and under the FAIR principles, I assume as well, right? That would fall findable, accessible, retrievable, etc.
Right.
Marino, anything else?
No, I think you captured the main points there, Cisco. Okay. And of course, we've got a few more sessions to discuss anything further as well the next few days. Well,
I think we're just 1 or 2 minutes over, but I do want to thank everybody for the contributions. It's a tough topic. It's a wide topic, but I think we converge on a number of really good ideas. Tomorrow, same time, same place, Rick Mathot will be on. Rick, will be speaking on stock assessment methods. That of course is the next step. So once you have the data, how do you do the assessments and how do you analyze this? It's that hugely important step between the data collection and providing advice. And Rick will cover that. And then remember the day after that, it's going to be how do we then take this data and what are the best practices for how do you provide advice. I want to thank everybody for your contributions, for your thoughts, and either for waking up really early or for staying up late at night or somewhere in between. Appreciate it. We will have the report for each session, but we'll also have an overall report soon after the 4 days of meetings. Is there any final comments or any thoughts anybody wants to offer?
I would like to say that I didn't have much to offer to this session, but just because we are in the process of analyzing all the data, so we have no best practices yet, because we are figuring them out. That's we are working on the large eDNA sampling campaign through all the Pacific coast with the Hake survey, and we haven't finished it because of the coronavirus. But I think we will be able to inform a few decisions, like maybe the sampling shouldn't be done during the night, because then the data doesn't match with the acoustic data or things like that. Because the acoustics obviously is done during the day. So maybe the best practice is to do it at the same time, so we can maybe infer or like analyze the information. I don't know, like what I'm trying to say is that we didn't finish it, so we don't have any best practices yet.
But there's a lot of reason to be optimistic, and I think that we had several folks on tonight about on eDNA, and I know that along the West Coast, and Norway is also devoting a good bit of effort on using molecular approaches, eDNA and others in fisheries. So I think this is one of the promising areas. I think, like Rick says, we got to figure out how to use it, because you know, to go from, you know, there's a lot of information, presence, absence, species, diversity, et cetera. How to put it all together to then get towards abundance is going to be a welcome challenge, but I think we got to get there, and probably the development of best practices is part of how we get there. So I look forward to seeing what you get, and maybe you'll be done by tomorrow. Maybe you can brief us tomorrow. But you know,
our aim is to get it done in the next 2 weeks.
2 weeks, really?
Well, finish the lab work, and then it's a matter of analyzing. But it's like partially analyzed, so we'll see.
And one of the recommendations is the next workshop, and so I think that we can fold these conversations and work that's ongoing naturally feeding into next workshop. So Maria.
Yeah, I think the conclusion is that the eDNA, like the large surveys, are happening right now. So the management or how these things should be done, maybe like we will get an idea of how they should be done soon, like maybe in the next year, you know.
Right. Agreed. Thank you. And I think it's time also for probably an ICES meeting or a Pisces meeting and all, and begin to, or an AFS meeting to start sharing, you know, these, what you're learning from these big surveys that are happening right now.
I think AFS is right now too.
Exactly. Is it happening right now?
It is. It's this week and last week.
Oh.
All online and intermittent.
Okay. So you're all attending like 4 conferences at once.
Yes, we're confused.
All right. Well, we've gone a little bit longer, but I want to thank everybody for your thoughts and input. This was really, really good and very helpful. First time we start this conversation, so it's always a little bit, you know, a little herky-jerky to start off with, but I think we wound up in a really, really good spot. So I want to thank everybody. And for those who can make it, I hope you'll be on tomorrow and for Rick's talk, and maybe we can continue the conversation we started today and fold it into that. Marino, any last words before we say good day or goodbye or good night?
No, nothing from me. Only thank you everyone for attending, and I look forward to tomorrow's session.
All right. Grace, can you stay on and Marino? Otherwise, everybody else, thank you so much. See you guys tomorrow, hopefully. Bye-bye.
Ciao, everybody.
Bye.
Yeah, bye.
Bye.
Bye.